Hello friends, welcome to my channel. In this video we are going to look at this topic, how to find number of onto functions. So here I have some theory for that. Consider a function f a to b such that the cardinality of the domain is m and the cardinality of codomain is n. Then the number of onto functions from a to b is given by this formula. So in this video we are going to see how this formula comes. We'll try to understand. Now to understand this formula, let us have a particular case, that is the cardinality of domain is 4 and codomain is also 4. So I have taken this condition and we know that the total number of functions from a to b is n raised to m, that is cardinality of b raised to cardinality of a. So in this case the total number of functions is 4 raised to 4. So these many functions, they contain all type of functions. I mean onto functions and into functions also. But we are interested in finding the number of onto functions. So I have to remove all those into functions from these many functions to get the number of onto functions. So therefore, number of onto functions is equal to 4 raised to 4 minus all type of into functions. So I have to remove these into functions from total number of functions. To remove those into functions, we have to identify all the cases by what mean they are into functions. So first case will be the function f from a to b is into because of three elements are not having pre-image. So diagram is like this. This is my domain A, this is codomain B. Domain contains 4 elements, say 1, 2, 3 and 4. Codomain contains 4 elements, so A, B, C and D. So I need to subtract all those into functions. So into functions can happen because of few elements not having pre-image. So I have to take all the cases. So my first case is in which 3 elements is not having pre-image. Okay, so I cannot consider all 4 elements not having pre-image. So let's take this case where any 3 elements is not going to have pre-image. So in this case, I assume that this A is not, B is not having pre-image and C is not having pre-image. So I've chosen 3 elements from codomain and I can do this choosing of 3 elements in 4 C3 ways. So I've taken one case of choosing first 3 elements. Now, coming to the mapping, I can map this one to only one element. So this has only one choice. I can map this 2 to this one element. This also has one choice and one choice. So this into function, because of 3 elements, how many functions we can have? So total functions which is not onto, that is into. So I'll add here total into functions because of 3 elements is equal to, so 1 into 1 into 1, 1 raised to 4, and this. In how many ways I can choose? So 4 C3 into 1 raised to 4. That is only 4 functions, 4 into functions because of 3 elements. So if you want, I can draw it. So this is my first function. This is my second function. All my A, B, C, and D. So all my elements in domain, they are mapping to D in my first function, and second function it will be mapped to C. Third function will be all my elements is mapped to B, and the last option is this. So these are the 4 possibilities of making into functions because of 3 elements. Everything is mapped to A. So these 3 are not having pre-images. Okay. Now let's take these 4 functions. So let's take second case. Second case, in this second case, we have to find into functions because of two elements. This time we are going to see two elements because of two elements. Let's draw. This is my domain, codomain 1, 2, 3, 4, C and D. So I have to choose only two elements which are not going to have pre-image. So for simplicity, let's take those two elements as A and B. So my A and B, they are not having pre-images. Remember that the choice of these two elements, it can be done in 4C2 ways. Okay, now coming to the mapping of first element, this 1 can be mapped to C or D. So this has two choices. Let's talk about this element 2. This 2 can be mapped to C or D. Again, two choices, likewise two choices, two choices. So total number of functions is 2 raised to 4. So I'm writing here total into function because of two elements is 4C2 into 2 raised to 4. Now let us draw one more case in this case. So what if I take this function? So we are in this case because of two elements. This subcase can happen in this case also. So 1, 2, 3, 4, A, B, C and D. So we have decided that this is not having pre-image and B is not having pre-image. Now there is choice of mapping this 1 to C or D. What if I decide to map this with C? Okay, so this is done. Come to mapping of 2. Again, this 2 has two choices and I decide to map this with C. 3, again I'm going to map with C. 4, again it has two choices but I have decided to map with C. So this case, we are taking in this because of two elements. But in this subcase, this function is into because of three elements. This function is already be counted in first case. So why I am taking this function again in second case? So these four functions are counted in this case also. So these four are counted 2 times in this. So these four functions are already present in this. So I need to subtract it. So now, till now, I'll write here. Till now, total number of into functions is equal to, I'll subtract this from this because this is larger in number. So 4C2 2 raised to 4 minus 4C3 1 raised to 4. So keep this thing in your mind and let's proceed. So into function because of 3 elements done, 2 elements done, only one case is left. Into function because of 1 element. Third case. Into function because of 1 element. So let's draw it. 1, 2, 3 and 4, my domain, and codomain contains A, B, C and D. So I have to choose only one element. That can be done in 4C1 ways in codomain. Suppose I have chosen that A is not going to have pre-image, so this 1 could be mapped to either B or C or D, so 3 choices. So likewise this 2 has 3 choices. So total number of functions 3 raised to 4. Okay, let us discuss this one. In this case we have this function also. Okay, so this is not going to have pre-image. This is already decided. What if I decide that this 1 is going to map with B, this 2 is going to map with C, this 3 is going to map with C, and 4 with this? Which function is this? So this is the function, this is the into function, not onto, because of 2 elements. So this function is coming from our second case. So this thing is already inside this. One more. So this is not going to have pre-image. This is already decided. What if I decide that this 1 is going to map with D, 2 is going to map with D, 3 with D, and 4 with D? What happens here? No pre-image, no pre-image. Which case? Case number 1. This one. So these two functions, they are already in these many functions. So this contains all two cases, all the functions which are already discussed in case 1 and case 2. So obviously what you will do, you will subtract from these many functions. What you will subtract? You will subtract this. Okay. Now this is the total number of into functions is equal to, what will I write? 4c1 3 raised to 4 minus of this thing, 4c2 2 raised to 4, and because of this minus, this becomes positive, plus 4c3 1 raised to 4. So these many into functions. Okay, and obviously I have to subtract these many into functions from my total number of functions. Total number of functions is this, 4 raised to 4 minus into functions. Therefore total number of onto functions is equal to 4 raised to 4 minus this whole thing. So outside there is minus, so this is minus plus minus, 4c1 3 raised to 4, this becomes plus 4c2 2 raised to 4, this becomes negative 4c3 1 raised to 4. Now let's relate this with our general formula for finding onto function, this one, n raised to m minus nc1. Okay, so this n is the cardinality of my codomain, so where in this case it is 4. M is the cardinality of domain 4. So so this 4 is my cardinality of codomain n 1, and this is 3 is 4 minus 1, so this is n minus 1 raised to n, plus nc2 n minus 2 raised to m. So this m, that is cardinality of domain, is always in the power of this thing. So this is going to continue up to this thing, n minus 1, n minus 1, n minus 2, n minus 3, n minus 4, up to 1. So this continues up to plus minus nc3 n minus 3 raised to m, plus this goes up to minus 1, alternate sign, nc n minus 1 and 1 raised to 1. How this 1 is coming? n minus 1. So this 1 is this. And how to control that alternate sign is taken care by this, n minus 1. So this is purely an example of inclusive and exclusive property. So here we have excluded, again we have included, and then again we have excluded. So this is all about how to find number of onto functions. Thank you.